Hello guys, welcome back to the recursive path. Today we are going to solve the second problem of Leetcode, that is the add two numbers. I hope you got the first problem, that is the two sum. If you didn't, please do check out the video, that is two sum. I have already uploaded it. Please take a look at it. In case you have any doubt on that, please do comment and share your thoughts. Yeah. So without wasting any time, let's get started with the second problem, that is add two numbers. Okay. So here is a problem statement. You're given a two non-empty linked lists representing the two non-negative integers. So this part is important, that it gives us two non-negative integers. The digits are stored in the reverse order. So it also says the digits are stored in the reverse order, and each of their nodes contains a single digit. Okay, so it's a linked list basically. Add two numbers and return the sum as a linked list. Okay, you may assume that two numbers does not contain any leading zeros. So this is also one of the condition, and expect except the zero number itself. Okay. So what question says is basically we have two non-negative integers which are stored in linked list, and those are like stored in reverse order. So what does it we mean by reverse order? Basically, let's say the number is 879, right? So how the linked list representation look like is basically 9, then 7, then 8. So this is how the number is being stored in the linked list. That is the first number, right? So this is just an example. Okay, let's take an example. This one, like 245 plus, sorry, 243, 5, 6, and 4. So numbers are basically 342 and 465. And if you're going to sum it out, so basic primary method, mass addition, this is going to be 5, 2 plus I 7, 6 plus 4, 10 is 0, 1 carry. So 3 plus 4, 7 plus 1, 8, right? So answer is going to be 807. So how are we going to represent it is basically 7, then 0, and then 8. So I think, yeah, this is what it actually asks as well. So output is going to be 708. That's why, right? And yeah, this is a explanation. Similarly, if L1 and L2 are 0, then it is going to be 0. This is the bigger example where 9999 are there and 9998. So we can take this example as well. So the first number is 9999. I think 1, 2, 3, 4, 5, 6, 7, 7 times 9, right? 5, 6, and 7, and we have 4 times 9 as well. Then 1, 2, 3, 4, and let's see if we can do it like so. 8, 1, 9, 1, 9, 1, 9, 1, 0, 1, 0, 1, 1, 0. Right. So that's how it is going to look like. So uh, the answer is going to be 100999998. And how we are going to represent it is basically 8, then 9, then again 9, then again 9, then 0, then 0, then 0, then basically 1. So that's how we need to like return, right? So there are some constraints as well given in the question. That is the number of nodes in each of the linked lists is basically from 1 to 100. So basically, number's length, a particular number length is going to be 1 to 100 only. Also, the node value, the value present at any of the node is basically 0 to 9. I think let me just to give you a gist of linked list as well. So linked list is nothing but a list of, what is it? Not even the list. It's a basically node itself, and which has a single node which has a value and the next pointer. So assume this itself a node which has the value and the next pointer of the same type of object. So what it basically do is, like, let's say in the first value we are going to store, let's say 8, and the next pointer basically it is storing the index of the next value. It says something like this. So this index, so address of this particular uh, next box, you can say, or next list node, you can say. Let's say the address is A, right? So A is being stored here. So we can access the next one basically by doing is my, let's, the variable name is for this is, let's say, current, that is cur. So current dot next will give me basically this. Similarly, it also has some value and it also has the next one. So the end is basically going to have next as null. So that's how a linked list is basically represented, right? So I think this is a very pretty and basic question that is being asked, and also I think what has been given to us, that is the reverse order, is basically a gift for us, because then we don't need to go to the ones place is already at the first head of the linked list, right? So what we need to do is basically just do the sum. So let me just particularly take an example. Let's say uh, my numbers as 879 345, right? So these are my two numbers. So how these two numbers are going to be represented? Ones place is nines, right? For 879. Then the tens place, that is 7. Then the hundreds place, that is 8. Similarly for the 345, the ones place is 5. The tens place is 4. The hundreds place is 3, right? So these are my two numbers that this is how these are going to be represented. Let me just name it as L1, and this is going to be L2, right? Now what we basically need to do is basically we need to add these two values, right? So what we are basically doing here is we are going to add 9 plus 5 is going to be 14, right? So 4 here. Then we are going to make a carry as well. So initially the carry is going to be 0. Now in this case it is going to be 14, so carry is going to be 1 now, right? So carry is 1. 7 plus 4 is going to be 11, plus 1 is going to be 12. So 2 here, again carry is going to be 1. Then 8 plus 3 is going to be 11, and 11 plus 1 is going to be 12. So that is going to be 2 here. And since at the end we have a carry, then it is going to be 1. So my output is going to be somewhat like this. Right. So 1224 is my answer for adding these two numbers, and this is how I. So basically, what I need to return is this particular list node, which basically has all these values in the next format, right? So next is going to be 2, next is going to be 2, next is going to be 1. That's how it is going to look like. So I hope you got the gist of this, like how we are going to solve it. It's like pretty basic primary level addition of two numbers, but how do we basically convert into code? So that is one thing that I think people usually takes a challenge of writing the code, right? So I can help you with the approach that we have done. So let me just write down the approach. So what we are going to do is basically we are going to create firstly, let's say, a dummy node, right? Dummy node, or what we can say, let's not call it as dummy, let's say the head node. It is going to be started with value 0. Why 0? Because this is my first one, right? We can translate this into code. I'm just writing as a pseudo one. So we once we are going to start with the coding, we'll do that, right? So this is going to be my head node, right? Or you can say as current node, and then I'm going to make a, what is it, current node as well. Current node, which is equivalent to my head node only, or start. And the next thing that I'm going to create is a carry, which is initially going to be 0 only, right? So now we have initialized these things. What basically we need to do, if you try to understand it like uh, in a normal way. So how do we do this? So let's take this example only. So basically we add till we kind of complete everything, and my carry is also exhausted, right? So what I exactly mean is, until unless I reach the end of this particular, either of this particular linked list, or this, or my carry is exhausted. Till that, I need to do some work, right? So what this translates into is basically until unless. So basically, I'm going to write this as a while condition. While my L1, sorry, uh, just a sec. While my L1 is not equals to null, either or basically, or my L2 is not equals to null, or my carry is not equals to zero. I need to do some work. Why this condition? As I already told you, until unless either my this I have reached the end of this or my carry is exhausted. Till that I have to do some work. Correct? Agreed. So this is where I need to do some work, right? So what I'm particularly going to do is basically I need to calculate my first value. So from where we are going to get my first value? That is from L1, right? So I'm going to get my L1 dot val, right? And why we need to do this? So let me just store it as let me just write down this in a better manner in like code like format only. So my int val1 is nothing going is like L1 is not equals to null, then give me L1 dot value, right? Otherwise, sorry, I'm going to use a tertiary operator here. So this is going to be like this, or going to give me this, right? So what it says is, if my L1 is not equal to null, then give me L1 dot value. If it is null, then give me zero for that, right? Because then val1 is going to be zero. Similarly, int val2 is going to be L2 is not equals to null, right? And then give me L2 dot val, otherwise zero. Now we have done this, we need to calculate the sum as well, right? So sum is going to be my val1 plus val2 plus the carry, right? Initially the carry is going to be zero, so there's it should not affect anything. But now, if my sum is going to be like greater than 10, then my carry needs to be what to say one, right? So I need to update my carry. So carry is going to be sum by 10. So what it will give me? It will give me. So let's say if my uh, sum is 11. So 11 by 10 is 1.1 basically, but here it is of type int only, so it will give me 1, right? So that's how it will work. Similarly, I need to do one more thing, that is I need to update my current dot next with the new node that I'm going to create. That is new node with the value as sum mod 10. So what the mod will give me? Basically, it will give me the ones place. Basically, so it's if let's say 10. So basically, I'm modding it with 10, right? So let's say if my number is 11 mod 10, it is always going to give me the remainder. That is going to be 1. Similarly, let's say if it is 12 mod 10, it is going to give me 2. So that's how it will work. So I'm getting that. And now what I need to do is I need to update my value, update my current list as well. Since I'm pointing it to first node, right? I need to point it to second as well. So my L1 is going to be L1 dot next, and L2 is going to be L2 dot next. So I think what we have done here is I think you pretty much got it is very basic, very simple in just a direct approach of adding two numbers primary level method. While what we have just done is basically converting the English into code language. That's it, nothing else. So this is pretty much is going to be what we have done. Now at the very end, what we need to do is since my current node, this particular node, you can also see that, right? Current node is going to be at the, since once this while loop is going to be completed, it's going to be at the last node, right? That's why we have created this head node, because head node is always going to be at the starting zero position that we have created, right? So now at the very end, we just need to return this head node dot next, because this is going to be my return condition. Why the next? Basically, because it initially it is going to start as like pointing to zero, right? My first value is going to be in the next only. So that's why I just need to return the next node itself. That's it. Whatever it is going to be present here in the value one, two, whatever it is. I hope you got the gist of this particular problem. Add two numbers and how we are going to how we have solved it, what approach we have taken. It is again, I'm saying this is pretty easy. What I've done is basically just converted this English language to code only. Okay, let's start with the coding and let's try to submit in the Leetcode 8. So let's try to do what we have done in the code in the approach part to try to code it out as well. So let me just create what I had thought of. So basically, we need to create a list node, right? That we have called as head node. That is going to be new list node, right? Of zero. That is my like pointing to current one. Then I need to create another list node that is going to iterate, right? To store my values. Let me just name it as current that we've also discussed. And I'm going to create a carry, which is going to be helpful. Now, what I'm going to do here is I'm going to create a while loop that we have discussed, right? So while loop is going to be my L1 is not equals to null, right? Or my L2 is not equals to null, or my carry is not equals to zero. This is going to be my condition for while loop. Why this condition? So basically, again, the first L1 should not be null, L2 should not be null, or my carry is not equal to zero. This particular carry is not equal to zero being added just because in the case that my last number that we have done, right, addition, then there is one carry that is left, that is one. Let's say in this example, this one, right? So the my last carry is going to be one in this at this point, so it is going to be zero. Then my last number is going to be one, right? That is not going to be added. So I can do it in two ways. First to like add this condition directly here, or I can like add it after this while loop. So I just preferred this one. You can do whatever you want. I'm going to fetch the first value from the L1. So what I'm going to do is my L1 is not equals to null. I'm going to use a tertiary operator as you have discussed. So L1 dot val, otherwise give me zero, right? Similarly, int val2 is going to be L2 is not equals to null. Give me L2 dot val. So why this condition is necessary? You can ask this because this condition, this particular tertiary condition is required in case one of the value is like smaller, right? So let's say L2 is smaller here, while L1 is like much bigger number. In this case, what will happen is like L2 will get exhausted early, while L1 is not going to be get exhausted, right? So in that case, L2 values every time is going to be zero because in these conditions, let's say the last ones, right? So yeah, now I need to calculate the sum. And sum is basically going to be val1 plus val2 plus carry. I need to update my carry by sum equals to sum by 10, and I also need to make one more thing, that is my current dot next is equals to new list node of sum modulo 10. Why we have done this? This is basically going to my now my current is going to point at new value that we have calculated, right? By creating the sum. Similarly, my current dot next current equals to current dot next as well. So what we have done here is I have updated my current as well. Now this is basically I'm uh, trying to add the next value, right? Next list node, but I haven't updated my current, right? So I have to update my current as well. So I have updated my current. Now, if my L1 is not equals to null, then I need to write it down as L1 equals to L1 dot next. L2 is not equals to null, then I can write L2 is equals to L2 dot next. These are basically the update conditions. Now, once we have all done this, we are just going to return the head node dot next, right? So I hope you got this. I think what we have missed here is basically the update condition for the current. Uh, so yeah, I think you have catched. You're going to catch it as well. So basically, at this point, once we have like stored or created the new node, we need to update the current as well. So there is one more line that is going to be present here as equals to next that we need to do. So this is going to be curly dot next. This is how it is going to look like. That's what we have done as well. So let me just give you the this. This is basically my head node. This current is basically for adding and traversing the list. And this is my going to carry. Or you can call this as placeholder as well. Right. Now what we are doing here is basically iterating over the iterating over the linked list. Now at this checkpoint, what we are doing here is basically calculating the sum, right? So sum the digits and the carry. Here we are going to here we are going to calculate the new carry. Here we are basically creating the next node with the single digit. That's it. And these are my update conditions. So let me just write it down as well. Uh, Move to next nodes. And, and I just need to return the next value. Return the actual head node from, let's write as head dot next. So if you've done this correctly, it should run with all the test cases. Let's try it. Yeah, it runs with all the test cases. If I click on submit, yeah, it gets submitted as well, right? So it is pretty simple, pretty easy, basic solution. I think you got the gist of this particular problem and how we have coded it, what the approach is, and all the things. In case you have any questions, please do comment it out. And thanks for watching. That's my time. Thank you.